Okay, so like I said, watch how much textures. The texture demos, I haven't been able to get them all translated into Joggle. So the texture code is still a little bit of a weird state. But let's first explain the idea of texture. Well, first, here's a texture demo. The point of textures is to take a photograph and wrap it around geometry. So for example, that's this picture wrapped around a sphere. Okay, so obviously it's a flat picture. The flat picture is being wrapped around a sphere, and you can kind of like down here at the South Pole, this whole bottom edge has been put to that point right there. Yeah, there's no really good way to wrap a flat rectangle on a sphere, but you know it works reasonably well. I mean, this picture was taken by taking a picture of the Earth and unwrapping it. So there's the, you know, if you look at this picture, that's the South Pole stretched across the whole screen. So then when you kind of wrap it back around the South Pole in this picture, it kind of looks okay. It kind of looks okay. Okay. So this whole edge is at that point right there. And those things radiating out like here are these here. Then the same thing happens at the North Pole. There's the point where everything is at. This whole top edge is at that point there. And those lines radiating out from that point are, you know, lines going down like that from here. And then the rest is pretty much just normal. Things are really distorted at the end. Okay. So how does this get done? Well, what I wanted, and these books weren't doing it, they were doing fancy examples. What you really want is a simple example. The most basic thing is, how do you texture map a rectangle? Then we can talk about a sphere, because a sphere is way more complicated. So let's talk about what it means to texture map a rectangle. And then we can talk about what it means to texture map a more complicated piece of geometry. This first demo was just a sphere. The second demo these are the demos from this one textbook. These are the demos from this book here. Okay. The next demo is even more elaborate. Oh, what happened here? Oh, that's not the main. Oh no, I'm sorry. This demo. Yeah, this thing's got a bunch of different shapes. I forgot. This demo is actually kind of complicated because it does a bunch of different shapes. Now, when you texture map something that was meant to represent the Earth on a cylinder, it gets pretty weird looking. Okay. So, and then on a cone and on a cube. I can't remember if there's a way to change the let's see. Oh, up and down, the up down arrow keys change the texture, the left and right arrow keys change the shape. Okay. So there's a torus with the world painted on it. There's a brick torus. There's a fractal torus. I'm not sure what that is, just some sort of metal-like texture. Okay. Now, actually, the bottom line, the actual first thing I want to talk about is a cube, like just one face of a cube. Like this is a good example, like what's being done right here. One face, a flat square face of a cube. If you understand that, you can understand these much more complicated ones. So that one has this texture painted on the face of a cube. So here's how this works. The image is an array of pixels. Like this one is, oh, let me open it in Earthframe. Where's Nova? It's 128 by 128. Okay, so this is a 0 to 127, 0, 0 to 127. So you have 127 pixels, 128 rows and 128 columns of pixels. Okay, so it's a bunch of little pixels. It's just a bunch of square pixels. Right now, that's the image. Okay, now the image is just going to be loaded into a two-dimensional array. So you can think of the image as a two-dimensional array. Now, over here is geometry in space. So over here, I have 4 vertices in space. So this is some x0, y0, z0, x1, y1, z1, x2, y2, z2, x3, y3, z3. Okay, so these are points in space. Okay. And usually what you do with them is you create, not to draw a square, you create 2 triangles. Okay. So we'll make a triangle that is the, if I call this V0, V1, V2, and V3, I can make a triangle out of V0, make a triangle of V0, V1, V2, and another triangle. It'll start, say, notice that this triangle, this triangle goes V0, V1, V2, goes V0, V1, V2. So the triangle's got an orientation that looks like this. That matters. We'll see that right. What we're doing now, it kind of matters if this triangle is ordered clockwise or ordered counterclockwise. So if I went 0, 1, 2, it's ordered clockwise. So let me do the next triangle also ordered clockwise. So the next one to do it clockwise, it doesn't matter if I start here or start here. I can do it V1, V2, V0. Okay. So these 2 triangles make up a square. And I want to paint this picture on that square, on those 2 triangles.
To be ones.
Let's see.
Oh,
that's let's see. V0, V1, V2, V3. And then I'm doing it wrong here. This one was V0, V1, V2, V0, V1, V2. This one should be V1, V3, V1, V3, V1, V3, V2. Yeah, V1, V3. Yeah. So that way they're both orientated clockwise. Okay. Now notice there's a row of pixels here, and I want that row of pixels to go across here. There's a row of pixels here, and I want that row of pixels to go across here. But notice that the row of pixels is over 2 different triangles. That, so this triangle is going to have essentially half of these pixels going down like that, and this triangle is going to have the other half pixels. Okay, so essentially this picture is going to be drawn on 2 triangles. Half the picture on one triangle, and half the picture on the other triangle. Okay. Roughly what I do is tell OpenGL what the mapping is. What's the mapping between this and this? And then OpenGL is going to do all the work for us. So for example, let me use Google. So this is from 0, 0 to 0, 127. And this is going to be, down here would be point 127, 127. And this would be 127, 0. All right? No. 0, 127. And this one is 127, 0. Oh, this one's going out. Okay, go. So row 0, row 1, row 2, up to row 127, column 0 up to column 127. Okay. Right. So these are called texture coordinates. The coordinates over here are, well, actually, that's not quite right either. these are image coordinates. We're gonna have three coordinate systems: image coordinates, texture coordinates, and 3D coordinates. Okay? And that's one of the things that makes this a little bit tricky, is there's gonna really be three coordinate systems. The picture is in pixels. So it's got 127 rows and 127 columns. So if I give, 50-50 would be 50 columns over and 50 rows down. Okay, that would be one coordinate system. Now here there's three-dimensional coordinate system. This is a point in space, this is a point in space. So these are, this point here is halfway between x0 and x1, whatever those are. The third coordinate system is called texture coordinates. And the way texture coordinates work is, in this picture, need more colors. Blue is going to be pixel coordinates. So blue is going to be pixel coordinates. And green is going to be texture coordinates. What texture coordinates does is it makes this corner 0, 0. It makes this corner 0, 1. Makes this corner 1, 0. It makes this corner 1, 1. Okay. So in texture coordinates, x goes from 0. We'll see. Let me think. There's always this idea of when you have two coordinates, is this one horizontal or vertical? Yeah, and it gets really messy because in geometry, we do x, y, right? So this point here is over x, up y, and we write it x, y. Okay. Right. So x is how far over you are. That's the first coordinate. But suppose I gave you a two-dimensional array. Okay. That's a 3x4 array. Okay. Where is 2, 1? But notice that now the first coordinate is going up and down. Here, the first coordinate is going left and right. And why that ended up happening in the world is really a mess. Because in graphics, it's always really confusing. If this is an array, the first coordinate is, I would think, the rows. But if this is geometry, the first coordinate is moving me left and right. And whenever you think of a picture like this, you don't know when somebody gives you a first coordinate and a second coordinate if they're going to think of it as array-like or geometry-like. And it really is 6 and 1/2. You can't tell if somebody says 27, 32. If it's in a math class, that's x equals 37, y equals 32. If you're talking about an array, that's the 27th row and the 32nd column. But if you're talking about a picture, you don't know which one they mean. Because a picture can be thought of as geometric, or it can be thought of as an array. And even OpenGL, they're very sloppy about this. They kind of go back and forth. Sometimes your pictures are array-like, and sometimes your pictures are geometry-like. If I remember right, texture coordinates are geometry-like. But pixel coordinates are array-like. Okay. So did I do the pixel coordinates right? If we think of the pixel coordinates as array-like, okay, 0, 0 is up here, the upper left-hand corner. Okay. Then if this is array-like, that's the first coordinate is rows. So this one down here would be 127, 0, because that would be from row 0 to 120. This one over here would be, Well, I'm in row 0 and column 127. Then this one's 127, 127. Okay. Now, texture coordinates, if I remember right, texture coordinates are geometry like. So 0, 0 here, this corner would be over 1. That would make this 1, 0. And this would be down 1, but you're still in the same, you haven't gone over, so this would be 0, 1, and this one's 1, 1. The difference between, okay, the main thing about texture coordinates is that it doesn't matter what the dimensions of the picture are, 0, 0, 1, 1. Even if the picture looks like, this is kind of odd, even if the picture looks like this, when you do texture coordinates, this one is 0, 0, and this one is 1, 1. Even if this thing is 3 times wider than it is tall, that's 1, 1 down there. Texture coordinates are scaled to be this thing is a, you think of them as 0.5 means what now? If they're scale coordinates, 0.5 means what to you? The middle. Yeah. Doesn't mean, yeah, it just means in the middle. So 0.5, so 0.5 is the center. Halfway down, halfway over. So texture coordinates are a scale coordinate where 1 means all the way across or all the way from left to right or all the way from top to bottom. So pixel coordinates are not scaled. Pixel coordinates are how many pixels do you have across, how many pixels do you have down. Okay. Texture coordinates are always 1 unit across, 1 unit down. And then over here, I've got geometry, real geometry coordinates. And real geometry coordinates are just where that is and where that is. Okay. Okay. So now, if I want to take this picture and map it on this rectangle, I have to go through a whole bunch of steps in OpenGL. First, I have to tell OpenGL what picture I'm using, what the texture is. So I tell it what picture, for example, that picture is a file on the hard drive. Okay, so you have to tell OpenGL I'm using that file on the hard drive. Okay. Then you have to tell OpenGL, okay, now when I tell OpenGL what geometry to put the picture on, I actually do it 1 triangle at a time. I don't actually texture a square. You texture a triangle. Triangles are the basic unit of everything in 3D graphics. So you don't put a texture on a square, even though I said this is like the most basic example. This is really still not the most basic example. The most basic example is texturing a triangle. Okay, so I'm going to texture this square. I have to texture 2 triangles. There's really 2 triangles there, and I have to tell OpenGL how to texture each one. Okay, so here's the picture, which is a square. Here's the triangle. What I do now is I tell OpenGL what texture coordinate goes to what geometry coordinate over here. So for example, I'll tell OpenGL that this is going to be the point 0, 0. Okay. And I'll tell OpenGL that this is the point 1, 0. And I'll tell OpenGL that this is the point 0, 1. Now the green ones over here are texture coordinates. So what I'm doing is I'm taking this texture here and saying it goes over here. 0, 0, 1, 0, 0, 1. Now this is kind of interesting. For example, suppose I change it a little bit. Try to figure out what's that going to do. First of all, what piece of this picture am I using? I'm going from 0, 0 to 0, 1 to 1, 1. So I'm doing the same triangle again. So it's this triangle. but what would I see over here? I'm only gonna see half of this picture, but how's that picture gonna show up over here?
One is down, right?
Oh, wait a minute, I drew the wrong triangle, yeah. It's which triangle? It's 0, 0, 0, 1, 1, 1, so it's that triangle. Okay, that triangle, right? Okay, see, so first of all, I'm using 0, 1, 1, 1, 0, 0. I'm using those three corners. So I'm using the lower left-hand triangle. Okay, now how's it going to show up over here?
Translate.
No, well, I mean, obviously it's got to be moved over here. But you know, this you don't see. This is the picture you see on the screen. So when you look at this guy, what part of this picture are you going to see over here? Okay, see what's going to happen. This edge goes where? This edge goes from 0, 1 to 1, 1. So that edge is going to go like there. Then as you move up this picture, what are you going to do? You're going to move down this triangle. So what are you going to see over here?
Inverted.
Yeah, upside down. You're going to see half this picture upside down. Okay. Yeah. Now on your hand, what if I did it this way? Okay. 0, 0, 1, 1, 0, 1. Same triangle. But now what's it done? Flip twice, really. Flip this way and flip that way. You know, this corner here is going to end up over here. So it's going to be flipped upside down and mirror image from left to right. Okay. So OpenGL is going to basically say this pixel here is going to go over here. As I work my way up to this pixel, I'm working my way, let's see. If I work my way up to this pixel, I'm actually working my way down to this one. Is that right? Yeah. So this edge here is this edge over here, which is really weird. Yeah. This edge over here becomes this edge over here. See? Where does this diagonal edge go? Well, the diagonal edge is going from 0, 0 to 1, 1, going from 0, 0 to 1, 1. This guy here is this diagonal edge here. Okay. So it isn't, yeah, so it's kind of, I mean, I was, yeah, what I'm trying to do is get this code to work the right way. And I'm having a lot of trouble getting it written because what I really want to do is be able to just change these parameters like that. I mean, what you do is you say, here's my, you tell OpenGL what pixel, what image to start with. Okay, so the pixel coordinates are just the image itself. Okay, so yeah, the pixel, you tell what image. Then you say, then you associate texture coordinates to each part of the image coordinate. Well, by default, OpenGL always puts zeros in the image. They put 0, 0 here, 1, 0 here, 0, 1 here, 1, 1. Okay, you don't choose that. If you open a picture, 0, 0 is the upper left-hand corner of the picture, 1, 0 is the upper right-hand corner of the picture, 0, 1 is the lower left-hand corner, 1, 1 is the lower right-hand corner. But then you go over here to your geometry. You say, here's my triangle. I pick 3 of these coordinates, but you actually don't even have to pick 3 of these coordinates. You can do funny things. Like, let's do a weird example.
I have a question.
Mm-hmm.
So here it just maps there
Yes.
or?
Yeah. You take this one goes here, this one goes here, and then in between you just interpolate.
There is no like what we did in the past, like origin moves around the origin something. There's no point of like that, right?
There's going to be some weird things we have to worry about. I mean, there's no rotation involved. Yeah, you're just going to take this edge and stretch it or squeeze it to fit this edge here. This edge here will just be either stretched or squeezed to fit on this edge, this edge will be stretched or squeezed to fit on that edge. Okay, here's a funny example. Question is, what do I see inside here? Where's this guy in the picture? Center. So there's the center of the picture. Where's this guy in the picture? His horizontal coordinates 1, his y coordinates halfway, so he's where? Yeah, it's the middle of this edge. Where's that point? Well, 0.5, halfway to the right and down to the bottom. So what triangle is it? It goes from here to here to here. So what will you see here? That slice of the picture. You don't have to show the whole picture. Notice that that's saying at that point in the picture, using the scale coordinate system, take that point in the picture, put it there. Take that point in the picture, put it, put that point in the picture there. Put that point in the picture there. Now suppose I wanted to show, suppose I kept this. How many triangles do I need to show the whole picture? 8. Yeah, and sometimes people do this because I would need another triangle for here, 2 more here, 2 more here, 2 more here. So then instead of using 2 triangles, just take this square and cut it in half. I might want to, for a variety of reasons, take this square and cut it up into lots of triangles and map all these triangles, have lots of triangles over here that these guys get mapped over to.
Wouldn't it basically, so like the brick example, instead of making it that whole thing just 4 by 4 bricks in the sense of the squares, it would make it 8 by 8 then? And just add a little bit more detail to it?
This is one, okay. Notice that the original picture is actually a 4 by 4 grid.
Yep.
So this guy knows nothing about these.
Yeah, he knows nothing about it, but in the sense of that,
Mhm.
wouldn't it make it then an RI seeing it an 8 by 8? Because if you're doing it so many times.
Oh,
or
no,
if you did
because
half-
this would only chop up.
Okay.
That would be this part right here. See, so it'd be 2 of these and 2 of these, and see, it would be,
And a half, yeah.
yeah. So if I actually made it 1, 2, 3, 4, 5, 6, 7, 8 squares, I would still be only doing this. Yeah. Now, if I made it 8 squares and I made each square one of these, then I would map this thing 4 times on it. So the idea is that I draw triangles over here, and any triangle can be any 3 points over here. Yeah, I can even do bizarre things. I wish I could get the code working for this. I'm having trouble translating this into OpenGL, but I could just say, I could just pick 3 points in here almost at random. And map, so I'll call this T0, T1, and T2, and put T0 here, T1 here, and T2 here, and then you just see this, that central triangle of that image would show up over here. Yeah, and you can do all kinds of weird things. What do people usually do? people usually take the four corners of the texture and put them on four corners of a rectangle. But see, that won't work with the sphere. With the sphere, things get, that's one reason why that sphere is so complicated. That when you texture map the sphere, if we go back to it, we can kind of see, the code is really pretty tricky. But if you go back to the texture map of the sphere, here's the image. Okay, there's the sphere. Okay. But you have to remember, okay, so the picture looks like this. The sphere actually looks like this. The sphere is made up of a bunch of little rectangles that you can cut in half, but those rectangles are going to be all, so what you're going to do is, like if you think of a globe, across the globe is a strip of little rectangles, and you have to imagine that strip of rectangles going across here, and then another strip of rectangles going across here. So you're going to do it in strips. This thing will be mapped to this thing, essentially the way you think of a globe, the lines of latitude and longitude on a globe. It really is a strip of rectangles, each one made out of two triangles. So you have to then think of this picture as a strip of rectangles going across like this. Because what you can't do is just somehow map this point to the North Pole, this point to the North Pole, this point to the South Pole, and that point to the South Pole. It just won't work. Yeah, it just won't give you anything. It'll run and it'll compile and I don't know what, it'll just draw something real goofy looking. You actually have to do it in strips. You have to take this top strip here, and it gets kind of tricky. You take this top strip and you think of it as made up of a bunch of little rectangles. Those rectangles are really triangles. Every one of these maps to the North Pole. So every one of these points here is the North Pole. But then these points map to points on that first, on this first on the first line of latitude below the North Pole. These go around that line of longitude, around just below the North Pole. But all these top points here, they actually are the North Pole. Then the same thing on the bottom. On the bottom edge, it's a bunch of rectangles. The rectangles are really triangles. Every point on the bottom edge is the South Pole. So they use the same texture coordinate. Every point here in texture coordinate goes to the same point in geometry coordinates. So all of these go down there, but then these go along the first line along latitude. Okay, and then from then on, you do rectangle. Then higher up, you'll have two consecutive lines of longitude or latitude. And then you do these as really triangles. This, and this will go to a triangle here, here, and here. This, and this will go to a triangle here, here, and here. This, and this will go to a triangle in the next rectangle. This, and this will go to a triangle next one. And it's just real tedious code to write using a bunch of nested for loops. Okay. So you're going to map pieces you map pieces of this picture to pieces of that sphere. So the picture is thought of logically as made up of strips. The sphere is made up of strips, and you map pieces of those strips to pieces of these strips over here. Okay, so that's the tricky part. The more straightforward part is mapping a picture to a square. That's the part that should be easier to demonstrate. And let's see if we can get the, when I try to do a simple example, I'm off by, I have one compiler error. Let's see if we can figure it out. Okay, here's the code. We can read the code. It kind of makes sense. Okay, here's the width of my image. Here's the height of my image. Oh, let's see. First of all, I changed the image I'm using. So those are probably not the right numbers. Let me fix that. No, I'm sorry. Yeah, those are the right numbers. Yeah. Okay. Okay. So I have these global variables. The pictures. So I'm going to use a small picture, 64 pixels by 64 pixels. Okay. Then it's a checkerboard. It's supposed to be a checkerboard image. So it's an array of a three-dimensional array, width, height, and then RGB RGBA for each coordinate. So it's a three-dimensional array, not a two-dimensional array. Over here, I've made it a two-dimensional array, but it's really a three-dimensional array because at every pixel you have an RGB and transparency. So it's a three-dimensional array going width, height, 4. Okay, so width, height, width, 4. Okay, right. And then I need something called a texture name. So there's a bunch of global variables. Okay, this is all the same as it is in every other OpenGL Joggle program. So this just sets up the Joggle window. Okay, this thing, what we're doing here is this, for this simple example, it came out of a book. Instead of loading an image from a matrix, from an image file, we're going to do exactly like you did in that first homework assignment. You know, where you just create an image out of a bit manipulation. Now, the one that was in the book, I can't get it to work. It looked like this. So I replaced the width with the one we used in the homework assignment. Okay, so there's the one we used in the homework assignment. There's the one, this was written in C, and I have not figured out a good way to translate it into Java. What that is in C is it's taking I, bitwise oring it with zero hexadecimal, okay, with 8 hexadecimal. So it's bit mapping I with 8 hexadecimal and checking if it's 0. So that's checking if bit 8 is 1000. So that's anding I with 100. That's checking if the 8th place is a 0 or 1. Okay, then it's oring that with this guy, which is doing the same thing, but with the J coordinate. Okay, and then it's going to OR those two. It's going to get 0 or 1, and then multiply that by 255. And it's going to create a checkerboard pattern. You're either going to, every pixel is either 0 or 1, white or black. But that's using the fact that in C, a Boolean is an int. See, these are Boolean values here, but Booleans are 0 or 1. Translating that into Java is a little bit messy, because in Java, a Boolean is a Boolean. So I haven't thought of a clever way to translate that into Java. So I'm just using this. So what this is doing is it's just creating a picture, what's something called procedural picture. I'm using a procedure, a function, to compute the pixels in an image. Okay? So it's referred to as procedural images. Instead of loading an image from a file, I'm computing the image. Okay, so this array could have been filled with the data from a file, or I could just fill it in with myself. So in this simple example, I'm filling it in myself rather than loading it from a file. I'll show you another example where it loads it in from a file. But here, to keep things simple, to not have to even do the file opening and code, it just says, let's just fill the array with data. Okay. Right. So that function computes the pixels in the image. Okay, then init is going to set up OpenGL. It's going to make the image. The image is a it ends up putting the image up here, so it's a global variable. So the image ends up being stored in this array here, so it's a global byte array. Okay. So then you have to start telling OpenGL where this stuff is. Okay, and then you get a whole bunch of fun. And this is where things just get messy. Every book I look at uses a different sequence of function calls here. Yeah, you'd think there'd be one way to create a texture, the right way to create a texture. And unfortunately, at least with this older version of OpenGL, it seemed that there were a gazillion ways of creating textures. And every book I look in has different code, and I'm having trouble getting them to all to work. Like this one's got one mistake. There's one line that doesn't compile. Okay. You basically have to tell OpenGL that you've got some pixels stored in something. Okay. Then you have to tell OpenGL to generate a texture. Then you have to tell OpenGL to bind the texture. Then you have to tell OpenGL what kind of texture parameters you're going to be using. So all this is telling OpenGL that there is an image that I want to use as a texture. Okay. Very messy code to just tell OpenGL that there's a picture I want to use as a texture. See, that's initialization. So this is all done once. This is supposed to just set up everything. Okay. Then here's the, let's see, make this a little bit more readable. Okay, so then this is the display function. Okay, I want to enable textures, just like before we had to enable lighting. So I have to turn on textures because OpenGL is weird. Everything's turned off by default. OpenGL kind of, for some reason, takes the point of view that everything should be turned off. So, and notice that the last thing they do is they disable textures. It seemed to be good style in OpenGL to turn on things and then use them, then turn them off. Okay, so you see this all the time. You turn a light on, you configure it, then you turn it off. So you turn on the textures, then you turn it off. Okay, then after you turn on the texture, you give another couple more commands telling OpenGL to more of these kinds of functions. I'm not even sure if these function calls could go up here. I'm not sure if they need to be called every single time or not, or if they have to follow after textures are enabled. So after texture enable, you set this texture environment, then you bind the texture. Notice up here, here was a call to bind texture. Here's another call to bind texture. Yeah, and I'm not sure why that gets called twice. Yeah, does it need to be called twice, or is it the person who wrote this was being a little bit sloppy? Okay, okay. So there's being bound again. Here's the interesting part. Now this is the part that does the mapping. This is the more understandable part. Okay, this is the part that's pretty straightforward. So inside a begin GL begin end, I'm going to do he's going to use quads instead of triangles. Okay, so he's going to do quads, or you can actually do squares. A long time ago, they deprecated the quads. Like, remember, this is very old OpenGL. So even in the old OpenGL, you have to go back to like OpenGL 1 to be able to use quads. Quads have 4 corners instead of 3 corners. The trouble with quads is you can't guarantee they're flat. 3 corners is flat. Three points determine a plane. You're guaranteed it's flat. If I give you like this point, if I give you this point, this point, this point, this point, this point, then this point up here, and make it a quad, the quad's warped. It's not flat. And OpenGL does not know what to do with it, and you'll just get bizarre outputs. If you do GL quads and you're not really careful that your 4 points lie in a plane, OpenGL will just get all screwed up and just give you garbage output. So they got deprecated a long time ago. You're supposed to just take your square and cut it into 2 triangles. Okay, but he's using a quad here. Okay. Notice he's alternating texture coordinate, geometry coordinate, texture coordinate, geometry coordinate, texture coordinate, geometry coordinate, texture coordinate, geometry coordinate. So the relationship is you go texture, geometry, texture, geometry. If we go over here, we can figure out what he's doing. The texture is the texture defaults to being a square, 0, 0, 0, 1, 1, 0, 1, 1. Okay. Let's see. If we do it with geometry, I think it's actually 1 here. And then he's got geometry coordinates. Now his geometry coordinates are -2. So if we think of that as in 3-dimensional space, so over here is 3-dimensional space. Actually, he's just using XY coordinates. If you notice, his Z coordinate is 0, 0, 0, 0, 0, 0. Okay. Well, actually, no. At some point he switches. That's kind of okay. So let's look at, okay, let's just do one quad. Let's do this quad first. So -2, -1. So that would be over here. -2, -1. There's that point. Okay. Then -2, 1. There's that point. Then what's next? 0, 1. That's that. 0, 1, and then 0, -1. So his geometry is this rectangle here. There's the geometry. That's his rectangle. Now, what texture? What's now on this point here, which is the one in the lower left-hand corner? He's putting 0, 0. Okay, so this becomes 0, 0. So this corner of the picture goes down to this corner down here. And then we'll see what one's next. 0, 1. So, which one did he do next? It's 0, 1 texture coordinate, -2, 1. So 0, 1 texture coordinate goes up here. Then 1, 1 texture coordinate goes to 0, 1. So 1, 1 texture coordinate goes over here. Okay. And then the 1, 0 texture coordinate goes. Now, the way we've done it, that's taking this picture and flipping it over. Right now, the way I put 0, 0, 1, 0 on the top edge, he put 0, 0, 1, 0 on the bottom edge. So this picture is being flipped over and drawn there. Okay, so that would take whatever this picture is, it would draw it there. Okay. And then I'm not sure what he's doing down here. He's getting no. This is 1, 1. Okay, 1, 1. So that's 1. Oops. 1, -1. That's this point down here. So that's 1, -1, 1, 1. That's this point up here. But then it gets weird. 2.4, 1. Okay. So that's x coordinate 2.4, y coordinate 1. So that's like over here, whatever. That's something over here. 2.4, 1. So x is 2.4, and then x is 2.4, y is -1. So that would be down here. Okay. Then so the rectangle is this one. Should be that one, right? For some reason, so there's a gap. These two quads don't touch each other. These two quads have a gap between them. Okay. They go from -2 to 0. on the x-axis, then they go from 1 to 2 on the x-axis. Where, does 2.4 make sense? Where does that number, does that number mean something? I don't recognize it.
1.414 makes sense.
The.
1.4, was that the square root of 2?
Yeah,
That's the ZZ axis.
so.
Oh, over here.
Yeah.
Yeah, and these things are pushed back, yeah. Yeah, that's the square root of 2, isn't it? Negative, yeah, 1.414, that's the square root of 2. Yeah, so these points are actually also pushed back a ways. Well, whatever, yeah, these others were all in the XY plane, but these are pushed back 45, actually, probably making it essentially 45 degrees, maybe 45-degree angle.
Then would that be the square root of 2 plus 1?
Yeah.
The first one? So
Yeah, 1 plus.
Oh, yeah, that's 1 plus the square root of 2. Yeah, so 1 plus the square root of 2. So this is 1 plus the square root of 2, and then it's pushed back. So it's at a 45-degree angle. Yeah, so it'll be tilted away from us at a 45-degree angle. Okay, yeah. So he's got one texture, flat with the screen, and one texture next to it tilted 45 degrees back away from the screen. Okay. All right, and flush. Okay. So there's the map. Now, a lot of people like to write it that way. 2 lines of code on 1 line, textures, vertex, texture, vertex, text. Other people alternate them, texture, independent lines. This is actually a nice way to write it. It's probably easier to read it this way than it is to read it when it goes, it's 1 line per line of code. Okay. Now, this doesn't compile. Oh, now the reshape just doesn't do anything. Okay, so all the work is right here. Okay, so one of the function calls doesn't compile. Okay, and it's online. Let's see if we can figure out what's wrong with it. I haven't had time. It does not like that function call. Okay, it doesn't like this one here.
Just comment it out. Let's see.
Pardon me?
Just comment it out and see what.
Oh, that's actually, yeah, you're right. Maybe it doesn't even need to be there. Yeah, you're right. That's actually like why not? Maybe it doesn't need to be there. Core dump. Now notice it compile, open, you're dealing with a primitive library. So it compiled, but it actually crashed bad. And it gave a core dump. Okay. Okay. So yeah, I hope we didn't hurt the computer. Okay, so it did need that, it does want that function there for some reason. Okay. Okay, so the next thing to do is look up that function. That's why I didn't have time to do it over, so. I want the function. If you go back to the folder on Joggle, I had a link. I don't. Okay, so there's the Joggle API. That's why I put it in there, because Joggle's not that much used. Googling for it is hard. Google depends on people. The more something gets used, the more Google finds it. Joggle's not used enough. Googling for it is kind of tough. I've noticed that Google doesn't seem to really know a whole lot about Joggle. So it's good to have a direct link to the Joggle API. Okay, now that's the Joggle API. Actually, I want also, there's the OpenGL API. Sometimes it helps to compare the function in both APIs. Okay, now we're interested in the function.
You should still have a copy, I think.
Pardon me?
I think you should still have a copy.
What do you mean?
You already have it in your
Oh, I should be, oh, I didn't know that, yeah. So let's see. Okay, there's the OpenGL version of this function. Okay, now what about the Joggle version of it? The question for Joggle is which, well, it's in here, GL2. Okay, because everything that everything we're calling are methods on this GL2 object. Okay, so that would be this, no.
I think we are GL2 under open, right? First one.
Was it? Yeah. Yeah, it's in this package.
Yeah, open.
Yeah, it's in that package. There it is. Now let's see. There's two versions of it. Okay, now there's two versions. Maybe we should use the other one. Maybe we're using the wrong one. Okay, now what do we need? Where was it down here? Oh, okay. Now, when you're debugging, sometimes it just helps to, rather than try to read across all those lines, just put one parameter per line and then start matching them up with the documentation. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 parameters to their 1, 2, 3, 4, 5, 6, 7, 8, 9 parameters. What about the other one? Is it different? Yeah, the other one's different. Yeah, but instead of being a buffer at the end, it's an offset into a buffer. Okay, so we probably want this one. Now, is that what we're giving? This is our buffer. This is telling us, that's telling OpenGL what's in it. It's an unsigned int. It's a buffer of unsigned bytes. It's RGBA. Remember, we made it a 4. Yeah, we did RG. We could have dropped the 4th one just on RGB. Then you'd make this GL RGB instead of RGBA. Okay. Now this one says unsigned byte. I think it is. Okay. Then no border, height and width, internal format RGBA. I hope that's right. Int level, I don't know what that, int target. Okay, now, which one of those parameters did the compiler not like? Let's go next, let's see, let's figure out, let's go back and recompile it and see if the compiler is telling us which one of those parameters it's not happy with. Okay, see there's 1, 2, 3, 4, 5, 6, 7, 8, 9 parameters. Yeah, and see the last one is a triple array of bytes. Okay, now does it tell us which one it doesn't like? Argument mismatch. Oh, cannot be converted to long. Wait a minute, but that was the other.
No, there's 2 of them. It's trying both.
Oh, it tried both of them. Oh, yeah. So yeah, we should be the first one. Oh, it's still, so it's not somehow the right kind of buffer. Okay, so it's not the right kind of buffer. So that tells us what's wrong. Okay, so this guy he's declared as a byte array, but it should be a buff. Oh, it should be a buff. So maybe we need to convert it. Maybe we need we'll see. Documentation wants a buffer. So buffer is something from, the Java NIO buffer. It's that buffer, a Java NIO buffer. That's Java NIO is the new input output library. How new is it? 20 years ago. But it's the new input output library. Okay, so there's the old IO library and there's the NIO library. And the NIO library was the newer IO library that replaced the older one. Just like swing replaced AWT. Well, at one point they decided their IO library wasn't very good, so they had the new IO library. So this is a buffer, not an image buffer, but an IO buffer. That's an IO buffer. A lot of times, buffer could mean image buffer, pixels, and things like that, but this is an actual IO buffer. So it's so what could we do to convert that to a let's see.
Byte buffer.
Maybe we could just yeah, is it? Well, I mean, here's just a big Hail Mary, as we say, Pat. Just where was it? That's probably not going to work, because if it was that easy, it might have been converted automatically. But here, at least I'll try. I'll say, can I just force it to convert it to that? Pardon me? Well, it wants it to be a buffer, which is the superclass of all these. So it's written to the interface. It's written to the top level class. So so I might as well just use the top level class. It's looking for buffer. So when it might be I could maybe convert it to a byte buffer. Well, no, the crash is because I didn't see that class file still there. Yeah, it's the same thing. This thing can't be converted to an IO buffer. So then, yeah, so now we have to figure out the run time. What I did is I started with a C program, and I'm trying to transform a C program into a Joggle program. So this is where I hit a roadblock. I don't know what to convert that guy to. I just took the original C buffer and changed it to it was a byte. In the original C code, that was just a byte buffer.
Yeah, we can't change that to a buffer because everything else in OpenGL wants to be a byte.
Yeah, so there's like these, but at some point I have to do something. Notice nobody else complained about this guy.
What if you make that a byte buffer?
Oh, okay, let's see. So that would but you don't declare a byte buffer using array notation. So what's the constructor look like for it? A lot of these don't have constructors. The NIO library is a pretty complicated library. What's the point of having classes that don't have constructors? If you have how do you get the objects? You get them by calling other methods that return you instances of those objects. But the library doesn't give you constructors. You have to call what we call factory methods. So so you have a class, and the class has no constructors, but there are other functions that will return you an object of that class, and you have to call one of them. And Java does that a lot in its more sophisticated libraries. So you get things like this. There's no constructors. See, there's no constructors for this class. So you have to get this class by calling either a factory method or a method in some class. Like here, see, these wrap functions. That might be, see, if you take a byte array and you wrap it into a byte buffer. Now, but that takes a single kind, but see, you have to look for things like that. Functions that take in something and give you out what you're looking for, rather than having a direct constructor. So these would be called factory methods. But they take in, well, I don't know if those an array of 3 is an array of 1. It's an array of 1 that's of, well, no, that would probably not. I'll keep looking in these books and see if I can find nice code for creating these texture maps. You know, we've seen the idea, we've seen the basic idea, but this is trouble with OpenGL. OpenGL, old-fashioned OpenGL, is nightmarish in the way you just keep calling massive numbers of these functions that just say configure this, and configure this, and configure this with all kinds of weird types. And you're just constantly, and if you don't get these functions just right, nothing works. Yeah, instead of you writing code, you're configuring parameters. Okay, I'll see if I can figure that out before Wednesday. Okay, we'll quit there. I'm gonna try one of these wrappers. Let's see, so that's byte buffer dot wrapper.
See, in order to save memory, I store the data in this nice compact compressed format. And the long underlying function.
Byte buffer, correct.
changes the value.
Oh, yeah, it was byte. It was in the byte buffer.
Yes.
Just leave out the bytes.
The wrapper.
And then you didn't save it every time.
Oh. Yeah, triple array can't be converted to single array. Yeah. So now it could be that we have to rewrite it instead of using a triple array, we have to just use in a lot, you just use array of rows. So you just turn this into an array that's now it's a one-dimensional array.
Let's do that breaks.
Yeah, see, yeah, that's a real common trick. Instead of using a 3x3 array, you'll use that's just one long array. But the trouble is now all my indexing has to be rewritten
Yeah.
because I can't use triples brackets anymore. So now maybe now where that matters is here.
Yeah.
So now all this has got to be rewritten. This should just be plus. Now what, no, you guys did this before. This is row I, so that's going to be row I times 64. Each row is 64 plus that. So I think
Same.
I got that right. So every row is 64 bytes. So that's I times 64 plus J, that's the column, plus 0, 1, 2, 3. I think that's the only place where the indexing is used. Now, so you go down here. Okay, maybe, okay.
What is this? The log file again. Same.
Now, see, since Joggle is calling into C code, when things go wrong, you just get really cryptic. Instead of getting nice exceptions, because what's happened is the blow up happened probably in the C code. Joggle called some C code, and the C code did an access violation, and the C code just basically just throws. I've never even seen these, but I'm sure these are the kind of error messages you get when you're in the C code, not the Java code. The Java code would throw an exception. See, what happens is the JRE is crashed. the Java runtime, the Java virtual machine crashed because something went wrong in one of the C functions it was calling. Not much help, is it?
Nope.
Compressed.
Maybe someone.
Not even a line number, yeah.
Nothing.
No, nothing.
The crash happened outside the Joshua machine, and yeah, see, right, says it right here. The crash happened in native code. So, yeah,
So,
didn't like this. Well, let's just pass it,
Check it, yeah.
just do that. No.
Remove.
yeah, we don't have to.
Now it's, now somebody else doesn't compile.
No, it's the same thing. It's not that byte array for buffered along.
Oh, byte cannot be converted to buffer.
Huh.
Well, let's try, look for some other constructor.
Yeah. Can't we, like, when we are creating a buffer, can't we at the first point create like a byte buffer then instead of just converting at the later point?
Well, but the thing is, see, there's no constructor for.
Yeah,
The question, like, you get these guys by calling something. I haven't worked with Java NIO in a while, but you tend to call, like, you open a file and it gives you back a byte buffer. So you get the byte buffer by doing calling something. Now there should be a way to just convert a byte buffer into convert a array into a byte a buffer.
There's an array.
Now here's the factory methods. There's something, there's the factory methods, but you just, you don't. I mean, we could create a byte buffer, then copy our data into it.
Yeah.
But that may, I don't know if that will work either. Do equals get. But this one just should, that's exactly what this should do. This should take our array and wrap it into a byte buffer. Let's try it again.